A kite flies horizontally away from the person holding the kite string. Assume that the string is stretched into a straight line. Okay, so there's a kite here flying and it flies horizontally. Say the person is here, the string is there. So it just go like this, and they said it's like 100 feet above the ground. The ground in here, this one 100. It's maintained to be 100 because they want to fly it horizontally away from the person. At a particular moment in time, the elevation angle of the kite. So that's angle, there's angle between the string and the ground, pi over 3. So set up like that, theta, this angle. Person is here, kite is here, it's flying this direction. Then we also have the elevation angles is decreasing. Yes, if the kite flies like this, the angles will be decreasing, right? Because it's here and it flies away from the person, so the angle keeps smaller and smaller. The angle becomes smaller and smaller. So decreasing at rate of 0.01 radian per second. So this means that we have d theta over dt, which is minus because it is decreasing 0.01. At this moment, what is the speed of the kite? Let's do that. Here the setup. We have a person here, and this person holds the kite. So the string is stretched. The kite flies horizontally. This is the ground. The kite, say the kite flies horizontally, so this direction. The distance they give us is 100. So this distance 100, and it's maintained 100 because they want the kite to fly horizontally. So fly like this. So assume that in this next position you see the kite is here. When it's flight until there, we have the angles. So I should extend it until here. So we have this angle to the ground. Say angle theta. And when the kite fly to here, the angles become smaller. So that's why they give us the rate here. So that's why the rate d theta over dt is negative here. So at the moment where we have the angle theta is pi over 3. So consider where theta is pi over 3. d theta over dt minus 0.01. 0.01. This one is when theta is equal to pi over 3. They want us to compute the speed of the sky. So let's say this length is x, it's a rainbow. And then when the kite moves to this direction, the distance keep increasing. This x keep increasing. So we now have the speed of the kite in this case correspond to the dx over dt. So dx over dt. To make sure it's the speed, I put the absolute value there of the kite. We need to compute the speed at the time when the angle theta pi over 3. So we compute that when theta equal to pi over 3. Now all we need to do is set up the relation between x and theta. So in this case, let's look at this right triangle. This is a right triangle. You have tangent theta 100 over x. Relation tangent theta 100 over x. And then all we need to do is derivative both sides of this equation and then plug in the values when we have theta equal to pi over 3. So let me do that. Here we have, I write like this, x times tangent theta 100. Derivative both sides. X and theta here, they are all function in terms of t. The terms increasing, the kite is flying away. Theta is decreasing, the angle is decreasing, the distance is increasing. Xt and theta t. But for short, let me just write x and theta. X tangent theta prime 100 prime. So here's I actually do d over dt. So let's write that. d over dt 100. So the right hand side is 0. The left hand side, this is a product rule. Let's use the product rule. dx over dt times tangent theta plus x times d over dt tangent theta equal to 0. So I use a product rule. Now I will use a chain rule for this one. dx over dt tangent theta plus x times tangent, right? So we have t map to theta at the time t. Call this u. You map that to tangent of u. So in this case we have tangent of theta, right? Or theta t. I wrote it as tangent theta. Call this v. dv over dt by chain rule dv over du times du over dt. dv over dt dv over du of tangent u times du over dt. So d over dt is of theta t. This term tangent prime secant tangent. So tangent prime secant square. Tangent prime secant square. We have secant square of u times the second terms. I just write down as d theta over dt. So that is this x times this one. So let's rewrite this. After we do the chain rules, we know that the left hand side is this one times secant square of u, secant square of u equal to theta d, theta t. So I just write theta d theta over dt. You can copy that here. Equal to 0. So they ask us to compute which angle is pi over 3. So let's get this data. Here's what we have. The x over dt On here we want to look at theta equal to pi over 3. So let's look at that at theta equal to pi over 3. On this for theta at pi over 3. So I just plug in theta is equal to pi over 3 everywhere. So this one is the one we need to compute. The question asks us that is the absolute value of that speed of the kite. That is what we need to compute now. Now I have dx over dt, theta at pi over 3. That's what we need to find. Tangent pi over 3 plus x equal to, we need to find x when theta equal to pi over 3. Remember that there is this relation, tangent theta equal to 100 over x. This one will give us x equal to 100 over tangent theta. In this case we want theta equal to pi over 3, 100 over tangent pi over 3. So remember that tangent pi over 3 is square root of 3. This one is square root of 3. So this term will be 100 over square root of 3. And with that I can also replace this one by square root of 3 right now. Secant of theta square that. So secant is 1 over cosine, the secant square 1 over cosine square theta pi over 3. d theta over dt is given to us minus 0.01 minus 1 over 100 equal to 0. This is what we have now. 100 divided by 100 is cancelled out. Minus 1 over square root of 3 cosine pi over 3 is 1/2, but we need to square that. 1 over 4 equal to 0. This one times square root of 3 equal to 4 divided by square root of 3. So these terms equal to 4 over square root of 3 divided by square root of 3. So 4 over 3. This one positive, so the speed of the kite is absolute value of this, which is 4 over 3. This is the final answer.